Welcome everybody. We got a beautiful question, and let me draw the figure. So we got a circle. Okay, that's nice. Now the circle has an intersection with trapezium. So at that particular point there is an intersection. So let me draw the trapezium. Okay, so let me name it as A, B, C, and D, and this is the center of the circle. Okay, now what are we to do? We have to find this area of the, what I would say, the chop that is being obtained when the trapezium cuts the circle. Okay, so that looks fair enough. Now after we have drawn, the most important part here is to obtain the values. Now we've been given the following values. This is given to be as 17 units. This is given to be as 16 units. This entire length is given to be as 44 units. Okay, so these are the informations that are being given, and with this information we will have to get the outcome. Okay, so now since this is given to be as trapezium, what I wish to do is I would like to get the height h. Okay, so for that I see that DC is equal to 16 units. So what I would do is I will create a parallelogram here, right? A parallelogram is created, and I will take this as E. EECD is a parallelogram. So this would mean DC is equal to AE is equal to 16 units, right? So AE is 16 units now. Let me place that. Now I want to get EB. So therefore my EB is going to be AB minus, from AB I take away AE. So AB is 44 and AE is 16. So what does that give us? 44, 16. 28. EB is 28, so this is 28 units. Okay, fair enough. Now drop a perpendicular from C to EB. Okay, so I have to drop a perpendicular. This is center, I'm taking it as O, and that is going to give me the height. So such that the perpendicular meets EB at F. So this point is going to be F. Now I know only EB, right? That's 28. So what I'm going to do is I'm going to take this EF to be as X units. Let EF be equal to X units. So this is a 90-degree angle, and I know that this is a parallelogram, so this is going to be 17 also. Fair enough. Now how are we going to get the value of H? That is an important thing. Okay, so let me take CF to be equal to H. Now there is one more information that we can utilize. CB is given to be as 25 units. Okay, given CB is equal to 25, so let us consider triangle CFB by Pythagoras. So what do we get by Pythagoras? By Pythagoras theorem, CF squared plus BF squared is equal to CB squared. This is 25 squared. BF, what is BF? We got the value for, we've got the value for EB, right? Not BF. So EB, how do you get the value for BF? So let me write that down here. Now BF is EB. From EB, if I were to take away this part, EF, I would get the value for BF. So EB is 28 and EF is X. So BF is going to be this value, 28 minus X. So when I say 20, so let me write this down. This is 28 minus X. So place that, 28 minus X raised to the power of 2. CF is H, we're taking it as H. CF is equal to H, so it's H squared. So I'm going to write an equation for H. So H squared is 25 squared negative 28 negative X the whole squared. This is my H squared. So let me take this as equation 1. Fine. So now what I'm going to do is I'm going to consider triangle CFE. So by Pythagoras, so what do we get by Pythagoras theorem? By Pythagoras theorem, you get CF squared plus EF squared is equal to CE squared. CE squared is 17 squared. So EF squared is X squared and CF is H, right? So you got to take it to the power of 2. So H squared is equal to 17 squared negative X squared. Now this is 2. Now can we relate 2 with 1? Of course we can do that. So this is going to be 17 squared negative X squared is equal to 25 squared negative of 28 negative x the whole squared. So you want to expand this, you get 25 squared negative of 28 squared negative 56x positive x squared, which is equal to 17 squared negative x squared. So this is 25 squared negative 28 squared positive 56x negative x squared. So you got a x squared with a negative x squared there and a 17x squared. So this and this can be cancelled, and you need to get the values. This is 25 squared, 28 squared, 17 squared. Now let me do that calculation. 17 squared. So I will just get the value for 28 squared, 784. Now 17 over this, let me use this part of the page. So I'm going to move 28 squared to the right side. 28 squared I'm going to move to the left side. So that's going to be 784 minus 25 squared is 625, and there is 17 squared, that's 289. So this added with 289 is this minus 625. That's going to be 448 is equal to 56x. So let me write this. 56x is 448. X is equal to 448 divided by 56. So 448 divided by 56, that's going to be 8. So x has got to be 8. I got x value, so substitute that. So you can get h squared. H squared is 625 minus 28 minus 8 the whole square. This is going to be 20. It's going to be 400. So 625 minus 20 squared, 400. This is going to give me 225. So we are getting a h value to be as root of 225, which is equal to 15 units. That's crisp. H is got as 15 units. So this is 15 units. Now you can clearly see that the h is actually running from the end of the circle to the other end, and there is a tangency there, right? So that would mean the value of h is spread equally. So this is going to be 15 divided by 2. That's going to give me 7.5 and 7.5. Okay, that is the division there for the h. Now the question is, we have to obtain this region. Okay, so how are we going to obtain this region? That is important. So for that, what I'm going to do is I'm going to actually draw a perpendicular. Now it is given that HOG are in line. So this is the point of intersection of the trapezium and the circle, and that is at G, and it's given in the question that HOG are in line. So the problem becomes easy. So what I'm going to do is I'm going to connect this thing to make a triangle. Now clearly this is going to be 7.5, right? So the required area is this part, as I mentioned to you. So how do I get that required area? So let me write that down. Required area is equal to area of this region. So this is a quarter circle. So area of quarter circle, and from the area of the quarter circle I subtract area of triangle COG, right? Now let us calculate the area of the quarter circle. So what is the area of the quarter circle? So area of the circle is what? Area of circle is equal to pi r squared. So as I mentioned to you, 7.5 is the radius. So 7.5 times 7.5. So that's going to give me 56.25. So I have 56.25 pi at one end, and the area of COG. So let me do that. Area of triangle COG is equal to half times base into height. The base is 7.5 and the height is 7.5. So I'm getting here 56.25 divided by 2, which is going to be 28.125. So take that out, 28.125. Now there is a pi there. I'm going to take the value of pi as 3.14. So this multiplied with 3.14, that's going to give me 176.625. I take away 28.125. So what do I get? I get 148.5 square units. So that is the required area. So what did I do? Oh, there is a small thing that we need to look into it. This is the area of the circle, but this is not the area of the quarter circle, right? So I need to divide by 4. So let me go back. So 56.25 divided by 4, that is going to give me the quarter circle, and that has to be multiplied with 3.14, and that is going to be 44.15625. From this I need to subtract this, so I'm subtracting 28.125. So 16 point. So this is not the actual value, so you have to strike this off. So the actual value is 16.0313 square units, right? So that is the answer, because this is the area of the entire circle, but we are only talking about the quarter circle. So we need to divide that by 4, and that would give us the area of the quarter circle. So from the area of the quarter circle, we take away the area of the triangle. That would give us the area of the shaded region, and this is an acceptable value, 16.0313. So this is a beautiful question. It combines so many concepts. Thank you everybody. Enjoy your day.